So you definitely see the CapEx efficiencies straight away. Fewer boxes. We've got no transponders now. Integrated optics into the routers. The network will scale to 10x where we are today. We can build a 1.2 terabit link on a routed optical network for roughly the same cost as a 100 gig link on our old legacy network.
All right. Welcome to Beyond the Fiber. This is a show where we break down technologies and discuss what it really takes to build next generation AI ready networks. I'm your host, Robin Olds, and in each episode, I sit down with the people building the networks, shaping the future of the industry, and sharing insights you can use. That includes what's working, what's not, and why it matters. Now let's meet my guest, Francis Ferguson, Distinguished Engineer for Lumen Technologies. Francis, welcome to Beyond the Fiber.
Thank you for having me, Robin. It's a pleasure to be here. This is my very first podcast, so exciting is a good word.
Well, I will promise to take it easy on you. And before we get started, I just want to make sure everyone knows that we will not be discussing proprietary or confidential information regarding Cisco or Lumen Technologies during today's conversation. So Francis, let's warm up by telling the audience a little bit about yourself and your responsibilities at Lumen Technologies.
I'm Francis Ferguson. My role is focused on network architecture, specifically how we design and evolve IP and MPLS networks and metro networks. I spend most of my time on next generation architectures, helping teams think through how technologies like higher speed optics, automation, telemetry are put together in a real world operational network. And a big part of my job is also bridging strategy and execution, working with engineering teams, vendors, leadership to turn long-term vision into deployable infrastructure.
And then for those that may not know who Lumen is, can you give us a little history of Lumen Technologies and maybe the companies that made it up in the past?
So Lumen has a long history in telecommunications. CenturyLink, Quest, Level 3, Wiltel, Global Crossing, and Warner Telecom are all sort of part of that history. The Level 3 acquisition brought a large inner-city fiber footprint. This really is the foundation of everything Lumen does today. It's the long-haul network that connects major cities, data centers, cloud regions across the country. Level 3 also brought a tier 1 internet network and a completely separate MPLS network with a wholesale enterprise focus, with both networks are built over the inner city fiber. Level 3 has about 35,000 on-net buildings in 80 cities, and we refer to that as the CLEC network. The CLEC metro is also ring-based architecture. CenturyLink, on the other hand, has a very large converged MPLS network and IP backbone. The ILEC metro is one of these gifts that we've got, right? The metro fiber is in 16 states, 1,400 cities, and roughly 130 on-net buildings. Each metro is its own IGP. We tend to abuse the term metro as the ILEC metros are geographically large. They can cover an entire state, 300 wire centers, north of 10,000 buildings. In 2020, the company rebranded to Lumen Technologies to reflect the non-traditional telecom provider and moving into a technology-focused company, and we're focused on, building out AI networks, building out fiber, cloud connectivity, and enterprise services.
That's the rich history there. And it'd be correct to say that recently Lumen, made a strategic pivot by focusing more on enterprise, wholesale, and AI-driven network services while moving out of the traditional consumer-based broadband space.
Yes, that's largely correct. Over the last few years, Lumen has made a very intentional strategy shift to focus on enterprise, wholesale, and the public sector, especially around high-capacity AI-driven networks. A key milestone on that shift was the sale of what we call Quantum Fiber, to AT&T. This sale allows us to double down on what we do best: operate large-scale inner-city and metro fiber networks, connecting data centers, clouds, and enterprises.
And I believe that closed in February of this year, February 3rd, with AT&T.
Yeah, so the easy bit's done. So we signed the paperwork. Now the hard bit's done, doing all the separation.
Got it. And I imagine that's going to take some time to do there.
Definitely take time.
So let's dive into the work that you've been doing at Lumen. But before we do that, I've heard you were at Cisco's Packet Optical Networking Conference, PONC, talking about Lumen's Metron architecture and network. Do you mind explaining what Metron is?
Yeah, maybe I'll give you a little background first, because it's a complicated thing. We have both fiber-rich and fiber-constrained metro networks. We build rings, mesh networks. We've got, as I said, about 160,000 on-net buildings. So we don't have the same capacity. And we also have off-net buildings as well, about 100,000 plus off-net buildings, where we can deliver the same services and capabilities to those off-net as we do to an on-net, just different goals. We also have many legacy metro designs, 1 gig, 10 gig, 100 gig, with different protocols, spanning tree, MSTs, various different versions. And we have Mo, which is also built on 10 gig and 100 gig technologies. And the last generation that we built about, which started in 2016, was SRMPLS, built on 100 gig technology. Metron, though, stands for Metro Routed Optical Network. And it's Lumen's approach to rethinking how networks are built for modern workloads like cloud and AI. We call this the radical simplification of Metro. With Metron, we're converging the transport and the IP layer. The backbones can be ring-based or mesh-based. It's all built on 400 gig technology, and it's bringing high-capacity coherent optics directly into the routers, into the Metro routers.
Okay. So with Metron, you're fundamentally redesigning the Metro architecture, but it sounds like you also are simplifying and collapsing layers that previously lived in separate operational domains. Is that correct?
Yeah, it's really simplification and convergence, not ripping out the Metro and starting over. We've been evolving this architecture over years. We deployed VPLS in 2012. We started using segment routing in 2016. So the control planes are already modernized. Where Metro comes into play is by collapsing the physical fiber and the transport layers. We're bringing the optical layer to the MPLS. The OLS is critical in this architecture. We're using the NCS 1001 as the OLS. It's uber simple. It's a dedicated point-to-point between two adjacent locations, interconnected by dark fiber, and the routers are connected to the OLS using OpenZR+. We call it a ROP. We call it a routed optical path. The OLS is integrated amplification. We're using the exact same design for short spans of 2 kilometers all the way up to 100 kilometers. Metron is doubling down on the DCI technology that's used by the hyperscalers. Give you a little bit of information. We can get up to 25 terabits of capacity between two routers over a pair of fiber. When adding capacity, it's as simple as adding optics or 400 gig optics to the routers. We're not building 25 gig networks. We're starting out with 1.2 terabits. That's just still massive amounts of scale for where we are today. The OLS also lets us simplify the operational visibility using something called OTDR. That's optical time division reflectometer. This provides a fingerprint of the fiber, identifying patch panels, splice points, OSNR, distance of the link. And when we get a fiber cut, we get the exact location of the fiber cut. This end result is faster isolation, faster resolution of fiber, fewer handoffs between teams, and a metro network that's much better aligned to our AI workloads.
It's interesting. You made a point, and just kind of calling out to the audience here. You said, yeah, it could get 25 terabits. That has a lot to do with the chipset that's inside of the platforms from Cisco, with Silicon One being able to handle the different capacity levels and speed. But it's just interesting that you brought that up. I could just swap out the optics and have faster speed.
More optics would be a better way to say it. There's another point maybe that's not clear. We also have adopted a data center-like spine leaf architecture in the buildings or in the data centers. So that's the Cisco 8201s. And that allows us to scale to thousands of ports, like 1 gig, 10 gig ports at these locations. So we've also got massive port scale just the way we're doing it. So we're doubling down on the technologies that the data centers have been using. But Metron 2 is also, it's the Ethernet-based access network to our service PEs. That allows our Metro network to allow any service, any port. So internet, VPN, E-line, ELAN, whatever you want to go do at whatever port speed you want to go do it at, from 1 gig to 400 gig. Pretty powerful.
So going back to the comments around routed optical networking, what were your first thoughts when the Cisco account team came to you and said, we have a great way of saving you OpEx by converging your layer 1, layer 2, and layer 3 platforms into one? It's challenging when you have an optical team and a routing team and their views on combining those.
I would say, honestly, my first reaction was a healthy degree of skepticism, right? Anybody says that they can converge layer 1, 2, and 3 into a simple platform and save OpEx, the engineer in you immediately gets to, well, what's the trade-offs, right? We were investigating OpenZR Plus about the time Cisco acquired Acacia, but once we dug into it, what stood out wasn't the cost savings. It was the operational simplicity, fewer boxes, fewer control planes, fewer handoffs between teams. It wasn't about doing something radical for the sake of it. It's about taking the architecture we already trusted, simplifying and integrating them more intelligently, And that's when it shifted from this sounds like it's interesting to this could really actually change how we run the metro.
So, what about like were there any challenges that you and Lumen faced along the way, and how did you and your team overcome them?
Yes, there's definitely challenges. We're still working through some of them. There's the inherent skepticism about the technology, like really we can do this. But when you converge routing and optical, right, you're asking teams that grew up in a very different domain to develop a shared understanding, especially around the open line system, the OLS. And fiber characterization came absolutely critical when you're operating a coherent based OLS. We had to invest heavily in training so teams understood real world fiber behavior, change process, repeatability, acceptance criteria. Things like fiber jumper lengths became important, span loss, reflection, and how OTDR data actually maps to the physical data points. We also saw cases where the OLS and OTDR made incorrect analysis assumptions about the fiber health visibility. So we've been working really closely with the Cisco BU and getting enhancements to better leverage the OTDR to fit our use cases. However, I would say we've overcome these issues by tightening process, data quality, refining automation focus, and we also making sure the human stays in the loop until trust is earned. It sounds complex. Networks are complex. This is the area where I think AI can add real value in data analysis in the very near future.
That's an interesting point about humans staying there until the trust is established. So, when you
Absolutely.
think about routed optical networking, where do the biggest economic benefits show up? Is it the CapEx savings, OpEx savings, operational simplification, or power efficiency?
You definitely see the CapEx efficiencies straight away. Fewer boxes. We've got no transponders now. Integrated optics into the routers. The network will easily scale 10x where we are today. We can essentially build a 1.2 terabit link on a routed optical network for roughly the same cost as a 100 gig link on our old legacy network. Right? So, that's your CapEx right there. But the bigger, more durable value shows up in the operational and planning simplicity. May not be there quite yet, but smaller boxes, smaller footprint, smaller power. When you collapse the layers, you see simpler network to engineer, how capacity is planned, and how issues are diagnosed. Still a bit of work to do there. We're still not at the end game. The other thing that I would say too that's probably important for us to say, we're a multi-vendor network. So thus standards are important, optical standards are important, routing standards are important, protocols and vendor interoperabilities are just table stakes for us. We're going to run a multi-vendor network, supply chains. There's many reasons to go through that. So it's really important to us too.
So, digging in a little deeper on something you just said there with the coherent optics, did you see cost savings by going to higher speeds?
How the biggest savings for us was in the transport side, collapsing the transport, the OLS, the 400 gig optics into the routers. So that's where the capex savings are. But I think there's just operational value, huge operational value in going down.
Well, how does routed optical networking change the way your teams operate the network today?
It fundamentally shifts how teams think about operating a network. The big focus for us right now is what we call day zero automation, designing the network so it's consistent, repeatable, and instrumentation from the start, not just bolted on at the end. From there, we're building towards day two visibility and control. Real time topology via BGPLS, alarms, always on performance monitoring using TWAMP, the OTDR we discussed for the fiber, streaming telemetry via GNMI. So our ops teams now have far better insight than traditional S&P ever did. We can also start looking at other things like operational signals you didn't have before, actual power usage, temperature, hardware health alongside traffic. That said, we're early in the journey. The foundation is there, but the real work is still turning all that into actionable workflow and confidence.
Focusing back on a VPLS, you mentioned earlier many providers are starting to look at other VPN technologies, again, like VPLS or even to EVPN with segment routing. Have you seen the operational advantages that have you making this transition?
I'll be candid. We're still running VPLS today, and that's very intentional. Right. Metron, the underlay is segment routing. PILFA provides 50 millisecond detection and restoration. Really important to us. We're not using PCE today. We're just using shortest path routing. Right. So that sort of gets back to the simplification. Could we use PCE? Sure, but we're not doing it today. We could use it in the future. So VPLS is much more about service automation and service interoperability to our existing metro footprint. A key point is even though we talk about Metron as being this new network, it isn't a separate network. It's built on the same SR, OSPF, IGP, the same reflectors that are already existing today in the network. So yeah, we kind of talk about it as being a separate network, but it's really just the evolution of the SR-MPLS network to integrate routing and optical into the same layer. EVPN is absolutely where we're heading, but we need to get to a critical mass to be able to take any advantage of it in that network. So we'll get there in the future. We're just right now, interoperability back to our existing network is the primary focus and why we're sticking with VPLS for the time being.
What advantages has implementing routed optical networking provided Lumen with, especially around Metron?
I would say just the ability to offer our customers service scale from 1 gig ubiquity, service scale of 1 gig to 400 gig without saying, oh, you can't do this or you can't do that. You can pick your port right now. And if you want to do internet, go choose internet. If you want to do VPN, go choose VPN. If you want to do something where you want to build your own overlay or underlay network using an E-line or an E-LAN technology, go do that. We really don't want to tell people how to go build their networks. We probably have opinions about how to do it, but everybody has opinions about how to go build networks.
So, what advice would you give somebody that's looking to implement routed optical networking?
Ooh, biggest advice is to embrace the new technology, but do it with discipline. Routed optical network only works if you're willing to simplify and standardize first, collapsing unnecessary layers, reducing protocol sprawl, and building repeatable designs. That's the key to automation. Automation is not something you bolt on. It's something that kind of becomes part of the design, right? This means consistent templates, clean data models, instrumentation from start. Technologies like open line system, OpenZR plus optics are relatively new, and they do introduce a learning curve. The key is to think in terms of the network, right? Not the box, and evolve deliberately rather than chasing features. Right? You know what I mean? Like build the right thing first and then build your products around what you've got.
Let's shift this discussion and talk about maybe the most exciting project you're working on right now.
I think AI and the potential for AI is really very, very interesting today. And I think that sort of leads to what I call as the digital twin or the network digital twin. We define the digital twin as the continuous update and mirroring of the IP optical and service layer. So how do you go about that? It's not just also about the Metron network, it's the IP network, it's the MPLS network. So all of that sort of is in play in the AI world. But leveraging the network data, real-time event-driven synchronization of the network to a digital twin is critical. It's all about this acquisition of data, the hydration of a digital twin. That's the critical piece. The network digital twin really is the foundation for AI reasoning. So you can observe current and past states, predict failures, congestion, degradation, simulate changes, and ultimately close the loop with automation to take action. But that's kind of the end state. I would say you can't get autonomy or network autonomy without building of a digital twin.
That's a great point about digital twin, and we're going to come back to that. But AI is like a really, really interesting conversation with any service provider. They're all talking about what they're doing from their perspective. Is there anything that worries you about that or excites you? I mean, obviously, digital twin is very exciting because it allows you to automate.
I mean, there's always going to be worries about AI, but I don't know that they're necessary. Like from a network perspective, I think that where it can take us is just amazing right now. But AI needs data. So if you think about it from an enterprise perspective or even from a network perspective, AI needs data. Data lives in the data centers and data centers need connectivity. But the reality is most AI data doesn't originate in the hyperscaler facilities. It lives out in the wild in the tier 2, tier 3 locations, manufacturing, retail, enterprise campuses. So AI models need the data constantly hydrated, not batch moved once in a while. That's where Lumen changes the game, delivering this AI ready network out to wherever you are in the world or wherever you are in our network. And then allowing customers to choose their internet, their MPLS service providers. I think that's really what we're driving towards.
So based on that, then, Lumen is really becoming a critical backbone for AI infrastructure. As clusters grow and require more massive deterministic connectivity, how does the underlying transport network need to evolve from your perspective?
I would say the underlying transport network is really just about scaling the fiber. There's insatiable demand for fiber right now,
Mhm.
right? That would be for the data center providers, the hyperscalers. But from the enterprise perspective, if I turn it around to them, with Metron, and we're developing something called multi-cloud gateway, which is a customer gets an on-demand access to cloud partners through a fully digital experience. We don't force an architecture. We let the customer choose the right mix of that technology. So if they want to have Amazon and Google and AWS, let them choose. We don't want to dictate what they want to do from a cloud perspective. But what we do want to do is get them to a digital experience.
And is that experience more like a private versus public network due to security concerns? I know DDoS is out there and can impact a lot of networks. Just curious Lumen's perspective on that.
Across the public internet, it's always there. But I would say that the internet can be attacked. Private networks, you've got unfettered access to whatever bandwidth you want. But any port on our metro network allows you the same connectivity, same speeds and feeds to go to the internet network as it does to a private network. But I do think that this is going to drive more private networking because I think that the data is in private worlds, medical facilities, manufacturing facilities. So I think that there's going to be more demand for private networks, deterministic bandwidth, always available, never getting attacked. I think that's where networks go.
There was an interesting Lightwave article on February 10th that discussed how AI and private connectivity fabrics, or PCFs, will result in $13 billion in opportunities and 58 million fiber miles by 2031 for Lumen. Any thoughts on that article?
The article's true. AI workloads are making massive demands, deterministic connectivity between data centers, metros, and cloud regions. The hyperscalers want to go east-west, and they can't really keep their workloads inside of a single data center anymore. They have to go east-west between data centers. That requires fiber, and they have an insatiable demand for lots of fiber, lots of bandwidth. They're even talking about petabytes of links between data centers, which is kind of insane. To support that, Lumen has and continues to invest heavily in the inner city fiber. We currently have about 17 million route miles of fiber. And as you said, we're targeting to have 58 million by 2031. So we will continue to invest. That's in expanding the fiber. But when you expand the fiber, you also then have to add new route miles, new paths in our network, more capacity. And then that's driving things like upgrades into our ILAs, your amplifier HUD, all over our network to support this investment as well. So it's a big deal. And when we build that, we're calling that our private connectivity fabric. The intercity network is our private connectivity fabric, but it's also the underpinnings for our MPLS networks, our internet networks, and for traditional customers that just want their own transport networks or whatever it means. It's a multifunctional network, but the scale is been driven by the hyperscaler.
You mentioned briefly about automation. So what is Lumen doing from an automation perspective, and do you have any goals around that?
When we talk about automation, I think it's about programmable interfaces to the devices. And that's generally for the pushing of configuration. We think of that around netcom. But if I take it a little further, it's about API first. We want to expose that to our customers in a digital consumption model. From a customer lens, it's about how do I digitize my network. So we're building the network so it can be consumed the same way customers consume cloud, programmatically, predictably, instantly via APIs. But the bar is exceptionally high there. I mean, let's not sort of confuse that. In a digital experience, from a customer's perspective, if the service doesn't work, then 99% right is still 100% wrong in the world of automation. Customers don't see partial success, they see failure. So automation has to be correct. It has to be repeatable, safe every single time. Customers don't want to break their network. So this means clean APIs, strong validation, real-time telemetry visibility, and closing the loop, giving them the closed loop feedback so they feel they have the control. Automation isn't about moving fast and breaking things. It's about moving fast without breaking things. And then I would say one other thing, trust is kind of an integral part of a digital experience. You've got to trust that this thing is going to do the things that we want it to do. So that's also critical to a digital experience.
Loved your thought. 99% right means it's still 100% wrong with that 1% out there. That's a great way to look at that for a customer.
Yeah, even as recent as we missed a VLAN in a template, we can repeat pushing that to the red network and it never worked. I mean, we were very, very close. We go fix it. and we get it right, but we need to get it right the first time for a digital experience.
Zeroing in on autonomous or agile network automations, also A&O, where AI, machine learning, and agentic frameworks are used to create self-configuring, self-healing, and self-optimizing networks, which is kind of a almost true resiliency. An example from a Cisco perspective for A&O is Cisco's crosswork network automation and AI-driven agentic ops framework. Coming back to you, Francis, on this, like, is Lumen looking at that? I know you mentioned the digital twinning earlier. I think that's where you were going with that.
So yeah, I mean, I'm a rubber hits the road type of guy. So when we talk about autonomous network operations, I mean, it really comes down to data, data, data. It's the model in the A&O world, we talk of that data as being sensors. We also can talk of that data as being telemetry. How do I acquire the data? This is the same discussion we had earlier about hydrating the model. So it doesn't magically make networks autonomous. You have to earn that badge of autonomy. It's the evolution of the network digital twin. It starts with standards-based telemetry, lean APIs, consistent data models across our devices so we can do things. You have to collect the data. You have to clean the data. You have to normalize it. You have to filter it. And only then do you feed it to AI. Otherwise, you're just overloading it and you're asking it to analyze and automate noise. We want to eliminate the noise. From there, it's a continuous loop. Observe it, train it, learn it, act on it, validate it. Each cycle, it's about trust, accuracy, and confidence. This isn't sort of a let's try this on a production network. We got to make sure that everything is working. Now, on that front, we're working with Cisco on Cisco Crossworks, evaluating that. I think it's got a lot of potential. But this really isn't a big bang moment. It's an iterative journey, and it's really not for Lumen. It's for the entire industry. There's a huge amount of possibilities there. The path is clear with high data quality, open standards, and closed loop automation. It is absolutely achievable. Now, it will take time and there's a lot of work that has to be done, but we are laying the foundation for that with Metron, right? Or any of our IP network.
I think we need to take a break from the easy questions and maybe give you a few hard ones. And I hope you're ready for this. So, yeah, you're walking into it. So here you go. If you had to explain your job or work that you do today to a 10-year-old, how would you describe it?
Tried that, it didn't work. But just like cars need roads to go to schools, hospitals, and stores, your computer and phones need special roads to send messages, videos, and AI data to each other. My job is to design and build those roads so they're really fast, always open, and super reliable. How about that? So when someone watches a video, downloads a game, go to a doctor, the information gets there where it's needed to go quickly and safely.
That's it. I like to tell my son, it's 15, like, the people I work with make your gaming experience faster.
Yes, downloading games. Yes,
Yeah,
absolutely.
I liked your analogy of the road. So it brings me to the next question. If you weren't doing what you're doing today for Lumen, what would you be doing instead?
Well, if it wasn't work, I really enjoyed the challenge of golf. It's different every day. It's a continuous learning sport. I love to learn. No matter what level you're at, there's always room to learn. There's always places to improve. There's always things you can do. It's just it's a problem you can never solve.
Perfect. All right. So I have just a few more questions before we close this session out. And the last ones are just back towards work. If you could redesign the service provider network from scratch today, knowing what we know about AI, cloud, and traffic growth, what would that network look like?
I mean, I would actually say that Metron is about as evolved as we're going to get, right now. It applies all the design principles that I think are really, really important for a modern network. You have to simplify, right? Simplifying the network so you have to simplify the network first. You can't standardize the network first. Why can't you standardize the network first? There are hundreds of standards, hundreds of ways of doing it. So you simplify it first, eliminate layers, standardize the network, and then automate the network. And if you do it in that order, right? Okay, you want to reduce the amount of automation you got to do because it's expensive development. I would say simplify, standardize, automate is where I would go. And Metron is a really, really good starting point for that. It's got all the right technology, all the right building blocks to go do it.
Okay, so this next one ties right into that. So, what do you think most people in the industry still misunderstand about building networks at scale Lumen operates at?
Wow. Okay. So scale isn't just about bandwidth. It's not just about bandwidth and capacity. It's about operational simplicity. And then that requires deep knowledge of the technologies and protocols. It really does. But maybe more importantly, it requires the wisdom and the discipline to simplify it without sacrificing visibility and control.
So thank you, Francis, for being here for the conversation discussion of Lumen's project, specifically Metron, that is powered by Cisco's Routed Optical Networking.
Robin, this was a lot easier. Not as bad as going to the dentist, okay? But on an anxiety level before it happened, it was pretty close.
It's an absolute pleasure to have you here. And this has been Beyond the Fiber. To hear more about where the industry is going and how we are going to get there, join us April 22nd at 1 p.m. Eastern, 10 a.m. Pacific for a tech talk on AI with Cisco's Jim Grubb, Chief Technology Evangelist. In that tech talk, we will pull back the curtain on the art of possible with AI. With that, I'm Robin Olds. Until next time, keep building beyond the fiber.